Hey everybody, welcome back to Young Engineers of Today. I hope you are ready to continue, well, finish really, Fusion 360, and then we're going to move on to, I'll probably have you guys download VCarve today, and then, if you're so inclined, I'll walk you through the process of downloading VCarve and everything like that, and then I will probably spend next week talking a little bit about VCarve, and then we'll move on to something completely different. So, yeah, that should be the plan for the next couple of days. As it stands right now, though, why don't we go ahead and, excuse me, why don't we go ahead and finish up with our CAM process. So I'm going to go ahead and open up Fusion 360. So it's just going to take a minute to start up. How's everybody doing, by the way? All right, well, I hope you're doing well. Oh, good. Thank you. I'm doing pretty all right myself. Thank you. But I'm glad to hear you're doing all right. My new hard drive came in. So pretty soon, probably after this class is done, I'm going to upload those videos, and then I'm going to go through the long process of reinstalling my OS, because that's the thing that really needs to happen. Well, we all knew this was going to happen, waiting for Fusion 360 to open. All right. So, looking pretty good here. I think we're just about at the point where it's going to respond to our inputs. Let's see here. Boop. Yes. All right, so let me go ahead and open up our current project. As you can see, we've done the bookshelf a few times. And it automatically places us into CAM mode. Our setup is still saved, as well as the two pocket cuts that we requested that it do. So let's go ahead, just verify and make sure that everything looks okay. Give it a second, because it doesn't want to respond right now. Yep, it's totally, that's okay. Give it a minute. There we go. Perfect. Close the simulation window. I don't know why the axis is flipped on just that one right there, but it should still cut out everything okay. So yeah, we can verify by simulating and seeing that the mill head is just cutting everything out. Although it's an unnecessary amount of stuff, we're not really going to be too incredibly concerned with that right now. all it's really doing is just making the cut longer. But regardless, that's all well and good. That's all done. So now, good Lord, it really doesn't like switching between the two cuts. Yep, really not a fan of it. Did it just... No, it just minimized. That was weird. Maybe I had two instances of it open, because it seems to be doing fine now. Anyway, just by really quickly double checking, we can see actually in this 2D pocket, I screwed it up, and you guys might be able to figure out what exactly I did wrong. Yep, I did. Well, I didn't miss this entire board. That's going to be a 3D cut, but I did miss this little doodad right here. So it's good to make sure that you've got everything selected. So unfortunately, well, we can still edit it, but if we go into geometry and click on the inside here, actually this should still work. So we'll make sure that the arrow is on the inside. Boom. By the way, this is how you edit a cut. And you see I got the little thing here for invalid toolpath. It should be okay as soon as we hit OK. It'll spend some time calculating. Yeah, here we go. We're getting the percentage, and boom, done. And it's added in this little one over here. So now we should have everything. Boom, 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 boom. Done. Now I've got that. We've got this. We can very easily tell that everything is going to be cut out here. No big deal there. Now we need to do one more set of cuts, and that is going to be a three-dimensional cut. Let me see here. I believe this is going to be... I believe this is going to be pocket clearing. Or maybe it's adaptive clearing. Let's see. No. Well, okay, so we're gonna do some pocket cleaning here. And again, we've got our 3/16 tool with all the default options. And in geometry, we're gonna go ahead. Hey, Mateo. We're gonna go ahead and select these materials. We'll make sure to select tool inside boundary, no additional offset. Got all that information right there. Keep everything there, default. We'll keep everything there, default, and we'll see what happens here. So why is this giving us red if we simulate it? Looks like there's a fair amount of stress on the tool there. But it seems to be doing all right otherwise. Well, regardless, it's making the cuts that we want, which is good. And then what we can do is we can go ahead and use a contour in order to finish up these blind tabs. By finishing up these blind tabs, actually by finishing up all of the tabs of the contour, we can make sure that they are smooth enough so that everything fits in nicely. Boom, boom, boom. Select all the things. Almost forgot that one again. Tool inside the boundary. We'll contour everything nicely. Not any retraction or anything. We'll just hit OK. We'll keep that all at the default. It'll spend some time calculating. And just like that, now we've got a final contour cut which smooths everything out nicely, makes everything much cleaner and crisper so that those tabs will fit much more easily into the slots. Watch it work its magic. Just wiggle around like crazy in that one. Oh, that's always funny to watch. I'm going to make it go backwards just because I want to see that again. And then... okay, anyway. Got a little distracted there. Perfect. So... we've got more or less everything now. We could contour the outsides of these in order to make sure that they look nice, but that would be a little bit overkill. Actually, we could do a 2D contour. Yeah, why don't we do that? We'll do a 2D contour on the outside as well. And again, you want to make sure that all this stuff is on the outside, just like before. Hit OK. And actually, this does a good enough job that we can just delete the pocket, the secondary pocket. So now we've got our 2D pockets on the inside of all of our different slots. We've got a 3D pocket for the blind tabs. Then we're contouring all of these so that they're smoothed out, and then we do a 2D contour around the outside of each of these. So now we use much less cutting to free the wood from the stock, various walls of the bookcase from the stock. And with that, we've actually pretty much got this bookcase prepped and ready to be sent to a CNC machine, save for one very important step. So now that we've done all that, we've generated all of our toolpaths and everything like that, we can click on Post Process up here. And this pops up, the post-processor folder. We'll reset the system default location. Let's just see what happens there. Okay, excellent. You're probably not going to have that error message. If you do, you can just click yes and everything should be okay. But it'll ask us where we want to output this to, what we want to name it. We can just keep it at 1001. Call it bookcase under program comments, because essentially the program comments, we're letting, so the program name or number is for the CNC machine. We give it a program number, it will be able to we'll be able to look it up on the CNC machine. The program comment will be something that we can recognize as human beings. You know, we can be like, oh, bookcase. Okay, cool. I know what this is supposed to be. Unit, the document unit is good enough. If we were working with a CNC machine that works in millimeters or something like that, we want to select that. If we were working with a CNC machine that works in inches, we want to use that. Most CNC machines don't really care, though. They'll be able to figure it out on their own, so you can just use document unit, which is whatever we specified here in the CAM stage, which we specified inches, so it'll use inches. That's usually a good default to keep it at, though. And you got a couple of checkboxes down here, reorder and minimize tool changes. Basically what it'll do is it'll look at all of the tools that each of these cuts uses that we generated over here on the left-hand side, and it'll change the order of them so that, let's say for instance, these two right here used 3/16, and then these two right here used 1/8 inch tools. So now we've got a cut that uses a 1/8 inch tool, we got a cut that uses a 3/16, we got a cut that uses a 1/8, and we got a cut that uses a 3/16. Would be kind of annoying because every time the machine would have to pause and we'd have to swap out the bits on the machine, the tool on the machine. However, checking this box right here, boop, boop, what that does is it'll move everything around. It'll actually probably just swap these two. It'll move everything around so that instead of it being all out of order like this, we'd have the two 1/8s right next to each other, and then we'd have the two 3/16 right next to each other. So we'd only have to swap out the tool once instead of 3 times. Basically, minimizes the amount of annoyance that you guys would have to work with if you were working with a CNC machine. Not always the best option, though, which is why it's a checkbox, because, for instance, as we've got right here, this 2D contour, what that does is that separates all of these walls from the stock. So it makes them free-floating pieces, which is not a great idea to do before you actually cut the holes out of the wood. Because if you don't cut the holes out first, there's nothing securing these walls down to the machine. And so as soon as it starts to cut, this thing's just going to start wiggling around everywhere, and it's going to be a sloppy cut. At best, nothing will move. But more than likely, it'll be some kind of sloppy cut. At worst, you could have pieces of wood flying everywhere, and that would be super bad. So, you also want to take into account the fact that sometimes things have to be in a specific order in order to ensure that cuts are safely made. Anyway, configuration folder contains all of the information it needs to convert a Fusion 3D file like this, a CAM file, into a Gcode file. And then you've got the configuration information where you can set up basically the base settings for your conversion to Gcode. In this case, we could use like the shopbot ISO.cps, which uses the shopbot ISO. Shopbot doesn't necessarily recommend using this one. Just if you're working with Shopbot, they actually want you to use the Shopbot open Shopbot configuration, post configuration. But we'll just keep it on Shopbot ISO because that also is more generic with other CNC machine manufacturers. It'll still cooperate and play nice with those. You can set up basically the different sorts of cutting steps and stuff like that. We'll keep it on all. That's nice. Output folder is where it's going to be put to, at least, for intermediate steps and certainly the final step as well. And then we'll go ahead and let's open the folder. As you can see here, it's empty. There's nothing in here. Actually, we've got doohickey in here. And that should do it. So let's go ahead and hit post. It's going to ask us to name it. We'll just keep it at 1001.nc. Hit save. And it will take its sweet time, and that's totally fine. Once it's done, though, get this window open called brackets, which is actually just a code editor that comes with Fusion 360. And it's going to sit here for a minute and think 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 some more. And it's going to come up with a failure. Invalid coolant mode, failed to invoke function on section, failed to invoke on section in the post configuration, failed to execute configuration, post processing failed. Wonderful. All right, well, let's see if we can't fix the cooling. So we'll edit these, and instead of cooling, we'll just say disabled. Reducing the number of potential errors. Generally not recommended unless you're familiar enough with your CNC machine to say definitively whether or not there's going to be a cooling system on there, because even if it does, if you say off or disabled, it won't use it for these steps, which could, be bad. Could be quite bad. Anyway, we'll go back to post. Hit 1001 again because it's got the dot failed at the end of the one that failed. And just like that, it was the cooling step that was providing a problem for it. And now we get this nice Gcode file up and running. Now, you might be looking at this and going like, this is weird, and I don't like it. But not to fear. Gcode is actually pretty easy to read, and I think it's kind of cool. Gcode is simply just a bunch of coordinates, and the machine extrapolates based on these coordinates how to move to the next location, or basically how to work with the cutting. So you've got basically a set of a bunch of different sets of instructions. You've got the name of the file, you've got the comment for the file, you've got the tools that it's using, which if the tools ever changed, you'd pop up, the Gcode would pop up with instructions here so the machine would know that the tool needs to be changed. It would probably return to a neutral position and ask you to change the tool out before it continued. Then we've got, size parameters and a few other ones. Then we've got the type of cut. In this case, it starts out with 2D contour 1, interestingly enough. And then we've got some initial parameters, starting position, things like that. And then it gives just a bunch of different sets of coordinates. So you can see X 18.3095, Y 11.9606, Z 0.2655, and then X 18.3102. So as you can see, it's moved just ever so slightly. Y 11.9606 9603, it's moved ever so slightly. Z 0.2623, it's moved ever so slightly. So it's a bunch of small points. And if we look down at all of these, the X moves the most dramatically, but it's still very small increments. And it's just a set of points for the machine to move along, and the machine will move from one point to the next with the tool engaged because the G-code has basically told it to have the tool be engaged. Feed rate, so on and so forth. F being feed rate, I believe. And it will move along these points, and it will basically just dutifully do the thing that it's supposed to. G-code is also used for 3D printing because of the same basic concepts. You give it a set of coordinates, and the 3D printer will just move to those coordinates with the tip engaged. You know, dispensing plastic 3D printing material, and building something off of that. So G-code is very versatile in the sense that it is useful for many different manufacturing machines, 3D printers, CNC machines, and everything that comes with that. So all the different types of 3D printers, all the different types of CNC machines, you know, mills and mills lathes, things like that. So I think that's actually kind of cool. But with that, that actually is everything you would need in order to be able to send this model to a CNC machine. Obviously, there are some things I'm not including here. You would need a machine controller. So you would need something that actually talks to the machine. Think of like printer drivers, you know, like what we've done so far is we've written up something in a Word document, and we've, you know, told it to you know, be printed out. But then there are printer drivers which would actually take your document and send specific instructions to the printer to print it out. What we've done is we've created our Word document, we've said, okay, it's ready to print, but we don't have any printer drivers installed because, as far as I know, none of us have CNC machines. So there would be no reason for you guys to download drivers for said CNC machines. Anyway, that would be the missing step in this whole process, is the driver for the CNC machine, which you would then send this G-code to and tell it to start up, and it would start up and control the CNC machine using the G-code, and the CNC machine would cut out, you know, your bookshelf from some plywood or whatever. Probably not plywood or particle board. It'd probably be actually some, like it might be plywood. Plywood is actually very likely. But either way, it would cut out your bookcase. So that's the way to do it using Fusion 360. And it's been, I'm sure, equal parts interesting and frustrating, or perhaps just frustrating, who knows, or perhaps just interesting. But either way, that's just a taste of 3D modeling. Now, this has been an engineering-focused 3D modeling program. There are other ones like ZBrush and Maya and stuff like that are more artistically based, that they're more like sculpting, as opposed to sort of this hard and fast modeling and measuring thing that we've been doing. Those might be something that you could try out if you're so inclined. You may be interested enough in this that you want to pursue it. This is fantastic for designing projects for like your own personal hobbyist work and stuff like that. Granted, it can do professional stuff as well, but this is a free version, which means that there aren't going to be it's not going to be as ready to go, and obviously there's going to be a license that you'll have to renew and stuff like that. And a lot of times with free stuff like this, that they can have stuff in their license agreement that you can't make stuff for, you know, monetization purposes, stuff that you're going to sell and things like that. You can really only use it for personal projects, but that really depends upon the company and stuff like that. Then you've got stuff like SolidWorks, which is very, very professional, used for a lot of professional engineering. This is as well. It's just, you know, we're using a free version, an educated version. So if you find that this is something you're interested in, I'd encourage you to continue with it. Spend more time getting familiar with it. Find out what kind of stuff you can do with it. What kind of, you know, can you make like a spaceship or something like that? You know, who knows? Maybe you want to make it in Blender, but regardless, it's a possibility. Now we could potentially spend some time taking a look at VCarve. That might be a thing that we'll do. So let me go ahead and close this down and cough. Okay, I'm back. Whew, it's pretty intense coughing there. Let's go ahead and save this because we added some new toolpaths with our setup. I want to make sure that still exists. And you go back into the model mode. Go ahead and close this out, because we're going to take a look at VCarve. And that's probably mostly going to involve actually going through the process of installing it today. Again, you guys don't have to. I just want to show you guys this in case you're curious and want to follow along. So if you follow the link I'm placing into the chat box, that'll take you to right here. There is not, unfortunately, which is why I'm not requiring anybody to download this. And I'm going to try and keep it a shorter set of presentations. Don't have to do anything. That's what I'm saying. If you have a Mac version, or if you have a Mac, I mean. So if you're interested in downloading this, just to take a look at it, you can go over here to trial download. And, well, you've got a few different links over here. You've got VCarve Pro and VCarve Desktop. The thing is, VCarve is not a free program. However, the trial is free. It's a limited piece of software. It's not fully functional like VCarve Desktop or Pro would be. So you think of it like a demo for, you know, old school games or something like that, because this is not going to be necessarily entirely representative of the final project. But you can use the trial version to cut a selection of free projects, and also you can include your own stuff and create some projects and stuff like that with some kind of severe limitations. But again, this is a trial version, and it's basically enough just to sort of get an idea of how it might be done differently. Good Lord. Okay, there we go. Phone keeps lighting up. I apologize. So let's go ahead and we can just download the trial software for VCarve Desktop if you just click on the download trial software next to it. Unfortunately, you have to subscribe to the Vectric e-newsletter. Oh no, Actually, you don't. You can just click that. Boom. You don't have to subscribe. You can just click on the download. And it will start downloading the trial software. Now here's the thing, VCarve is not exactly a immediately intuitive program to use. It comes with a lot of training material, and it's generally a good idea to check that stuff out. But again, not strictly speaking necessary unless you're really looking to pursue this kind of thing. Oh my goodness. So I'll go ahead and click on this and we'll get started with the installation. All right, I'll guide you through the installation. I agree. Desktop Trial Edition will require 379.3 megabytes, so on and so forth, and then we'll just let it walk through the process. It actually installs pretty quickly. Pretty quick install though. Once it's done, you can just go ahead and start up the trial version. And this is VCarve. Now, the reason why it's called VCarve is because the V stands for vector. The files that VCarve uses are vector files by default. So if you've ever used like Inkscape before, you've worked with a vector file. If you've ever looked at clip art in Word, you've probably looked at a vector file, at least modern clip art. Older clip art is bitmaps and stuff like that, but modern clip art is vector stuff. If you've looked at a billboard before, chances are you've looked at vector art. If you've looked at, oh geez, let's see here, like a billboard that has like a logo on it or something like that. Good Lord, there are so many things. A lot of company logos are vector art. And a lot of labels are vector art. A lot of very simple sort of drawings and stuff like that can be vector art if they're not pixel art. If you've ever looked at very, very simple drawn art in a game, if you've noticed that parts of the art move as opposed to the whole thing being animated frame by frame, then you're looking at vector art as well. And this might mean nothing to you. What is vector art exactly? Well, vector art is a type of drawing that is expressed in mathematical equations or is described in mathematical equations. And you might be like, that sounds weird. And you know, you wouldn't be wrong. It's an interesting way to store information about a picture. There are two different types, basically, of art. There's vector art and there's raster art. Vector pictures and raster pictures. Raster pictures are probably the ones that you're more familiar with. They're just basically a grid of pixels, and you put colored pixels into individual spots on the grid, and you get a picture out of it. So pixel art, a lot of pictures that you see, like, let's see here. Let's go ahead and pull up a picture of a skyline, because it's going to be a picture taken with a camera, which means it's going to be raster art. All right, here's a good example. So this is a picture taken with a camera. And this looks like, what does this look like? Atlanta, maybe? No, that doesn't make any sense. Anyway, point is I'm terrible at recognizing city skylines. But that's neither here nor there. No, that can't be, is it? Wow, okay. I'm really bad at it. I totally didn't even, okay. I thought that, well, never mind. Let's just ignore that. Now I see it. I totally see it. In which I don't recognize New York from a picture. Anyway. So far so good, right? Like this looks okay. This is raster art. Yeah. Yep. So this is raster art. Now raster art is just a grid of pixels. Now here is the thing about it. So raster art is only as good as the size of your grid. Have you ever tried to zoom in on a picture? Like, let's go ahead and zoom in right here. Notice how these pixels are all just sort of getting super big. Okay, I appreciate it. That does make me feel a little better, thanks. Notice how these pixels are all getting super big and blown out. That's because raster pictures have a finite amount of information. Since they are a grid of pixels, if we want to make this picture larger, all we can do is simply make the grid, just basically make the individual pixels in the grid larger. That's the best we can do. However, with vector art, and I know this is probably a lot of explanation, but it's kind of good to know the difference between the two anyway. With vector art, so raster, we got our grid of pixels, and there might be pixels colored. Let's try it this way. Boop, bam, and bam, bam. Ooh, right. Bam, bam. And just like that, that's basically how a raster image works, is each individual area is a pixel filled in with something. With vector art, we have a set of dots, just basically points, and we're drawing a line between those points. So imagine you guys, you've all taken at least some form of algebra. Remember graphing? And how a line like this might be y equals x minus 1. Because, you've got y equals -1. And then this is like x equals 1. Regardless, well, we got a straight line it's supposed to be a straight line that's expressed with a math equation. Vector art works in much the same way. Imagine that you have sort of a bunch of little graphs on a, oh nice, congratulations. You have a bunch of little graphs on basically an empty canvas. And you might have equations representing lines on them. And then those equations are essentially meant to be linked together and there's no real way that you would be able to do that with a single mathematical equation, but regardless, these equations can all be linked together. And if we were to remove the axes that I drew in there, you'd get an actual picture. Now, granted, zooming way in, this is going to be a grid of pixels just like anything else. But here's the thing. So if we look at this graph, right, y equals x minus 1, we can extrapolate this line both forward in the x direction and backwards in the x direction to infinity, right? Because we know what the answer is supposed to be. We can just plug in to x right here, and then we get a y out. It's as simple as that. So by using mathematical equations with a piece of vector art, we can actually expand, basically blow up or make larger a picture that's vector art without losing quality. So that's why companies use it for their logo. That's why the advertisers try and make billboards vector art, because they can make super tiny little versions to show people, and then they can yeah, exactly. If x equals 1, y equals 0. If x equals 2, y equals 1. We can extrapolate the shape of this line and the look of this line out to infinity. Basically, no data is lost if we zoom in or zoom way out. So the same thing can happen with vector art. We can take this line, the shape or whatever, and we can blow it up to like the size of the side of a building, and it's going to look just as sharp and as crisp. Pretend it looks sharp and crisp here. It's going to look just as sharp and as crisp as it did when we drew it on the computer, because all it's doing is you're taking these equations and you're extrapolating them out further. The other thing about equations, the fact that they're equations, means that they lend themselves very nicely to being interpreted by computers and translated into things that can be cut. That is to say, CNC machines. That Gcode, those are all coordinates in a coordinate system, right? The X, Y, and Z and all that stuff. Well, the output of equations, we get an X, we get a Y, we might get a Z as well. And that's just stuff we can just add to a Gcode file, and suddenly we've got instructions for a CNC machine. Just like that. So vector art lends itself very well to CNC machines, 3D printers, and stuff like that, because it's a very easy translation from a drawing that you've made or whatever to instructions for something to be cut out. And that's what VCarve is. It works with vector in order to create instructions for a CNC machine. Now, I'm actually going to call it a class here, just because we're getting close to closing time here. So why don't I go ahead and do the poll questions? Then we'll go ahead and leave it open for question and answer time. If you don't have any questions at that point, you're more than welcome to head out. We'll meet up again on Monday, and we'll spend some time going over VCarve. Now, again, I'm going to try and make VCarve be a very short set of lessons, because I know not everybody can download VCarve, and I know it's sort of tangential to what we've been working on. But it's interesting to see how you can convert vector images into three-dimensional CNC created objects. So we'll take a look at that. We'll take some time to sort of get familiar with it. Not too long, but enough to just sort of be like, okay, cool. And then we'll move on to another subject after that. But yeah, let me go ahead and do the poll questions, and well, you know the drill.